Now in this video, we're going to do some examples with Pythagorean theorem. So just as a review as to what Pythagorean theorem is, oh, I don't want it to be that thick. Sorry. Just as a review, if you give me a right triangle is one where there's 90 degrees there, and C is the hypotenuse. C is the special one. Hypotenuse means it's special. That means it doesn't touch the 90-degree angle. Again, this is just review from the last video. Then a squared plus b squared is equal to c squared. Okay, so remember that c is the only one that's special. So a and b could be flipped in some sense. You know, I could have called b a, and I could have called a b. This is just usually how we write it. C is the special one. So just keep in your mind where the hypotenuse is. So there's two. So basically how this is used is that if I give you the side lengths of just two of these sides, you can figure out what the third side length is. I can either give you A and B, or I can give you A and C, or I can give you B and C. And then you can figure out what the other one is. So let's do an example here. Let's say I tell you, here's our right triangle. Let's tell you that A is a length of 3, B is a length of 4. Then what is C? Well, you just plug into the equation. 3 squared plus 4 squared is C squared. 3 squared is 9. 4 squared is 16. That's 25. So that tells us that C has to be equal to 5. And so that's the that's sort of the easier of the two ways, is because you've already written the equation that you remember, a squared plus b squared equals c squared, and you just solve for c. There's nothing to do much beyond that. You just have to remember to take a square root. On the other hand, what I can do is give you what C and A are. So let's say this is 15, and let's say that this is 9. So this is our A here, this is our B, and that's our C. So remember, if I give you two sides, you can figure out what the third one is. It doesn't matter what those two sides are. You just have to remember which one's the hypotenuse, otherwise your math will get messed up. So a squared is 9 squared plus b squared is equal to, c is given, so that's 15. I'm going to use a calculator because these are bigger numbers. 9 squared is 81, and 15 squared should be 225. I'll double check that. Yeah, this is 225. Okay, so that means that b squared is, and you just subtract 81 to the other side. So this is 144. That's b squared. And so that tells you that b is equal to 12. And now you have all three sides. Okay, so those are the two ways. You just have to remember which one is C. So the first thing you should always do is identify what the hypotenuse is before you do anything else. Okay, and now you're probably wondering, well, okay, Tyler, why do I care about this at all? Well, it turns out that this type of problem is something that needs to be solved all the time. So I'll give you guys an example. need to get a new page here. Okay. So an example of this comes from baseball. So let's have, you got your batter up here, got the pitcher's mound, and I'm not a great artist by any stretch of the imagination. You got the pitcher on the mound with the ball, you've got home plate, you've got the catcher here, and you have the bases. Form a sort of diamond here. Okay. And let's say we have a runner here on first that's trying to steal. He's trying to steal to second base. Okay. The question is, how far does the catcher have to throw the ball? That's the question we want to ask. Okay, and it turns out that you can just do this with the Pythagorean theorem. But you have to know a little bit of baseball knowledge here, is that the distance between bases is 90 feet between all bases. So that's 90 feet, that's 90 feet, and that is 90 feet. Okay, so what you can do is you can note these are all at right angles from each other. So you can draw this purple triangle here. This is a right angle. So this distance, C, that is the distance that the catcher has to throw it. And we know that the distance between each base is 90 feet. So we really just have this problem. I'll redraw them. I'll redraw them in the same orientation. So this will look like an upside down triangle compared to what we were looking at before, but this way you can actually see the bases, how they fit into the bases. So this is 90 and this is 90, and this is C. So, and we're solving for C. That's 90 squared plus 90 squared is C squared. Okay, and then you can plug into a calculator. 90 squared plus 90 squared is 16,200. It's a big number. So this is in feet now. And then we just take the square root of that. So that means that C is the square root. So it is exactly equal to the square root of 16,200, but that's not a perfect square. So we only approximately know its square root to be, let's do 2 decimal points. This is 127.28 feet. So that is how far the catcher has to throw the ball. And there are tons of other things you can solve with the Pythagorean theorem, but that's just a cool example there.